All right, everyone, let's look at how we can prepare solutions of known concentrations. So basically meaning, how do we actually prepare solutions in the lab or in the real world that you can work with and do reactions further. So there are two main methods, and they are listed here. So the first one, second one is here below. So the first one says combine mass. So you put a mass with a solvent. So kind of dissolve something in a liquid. So you take a known amount of moles and number of moles and dissolve it in a liquid. And then you know what the concentration is. And the second one is you take a already known solution and you dilute it. So both of these methods, I mean, you should be kind of already familiar with in terms of just what you use in everyday life. I mean, you technically make solutions all the time. You probably just don't know what their concentrations are. So maybe let's just draw some of these ideas. So I mean, in the first option, you would typically like take the volumetric flask that you have here. That's a very nice volumetric flask. I'm very impressed with myself there. All right, and you take your little solute, so you know your whatever you want to dissolve. I think in this example that we're going to do here, it's sodium carbonate. So let's use that as an example. So sodium carbonate, and you have enough distilled water right to make up a solution once again, 1 liter, or is it a 2 liter in this case? Well, it's a 2 liter, a 2 liter solution up to the mark. And it says, well, you carefully transfer this in there, and you're going to carefully transfer your distilled water, and eventually you want a solution that has a concentration of, it says, suppose you need to prepare a 2 liter solution of 1.5 molar. All right. So let's say, for example, that's something that you need to do. All right. So that's situation one. I'll get to now how you would do that, but that's typically how you could make it. All right. So you put your solid in, and then you dissolve it in the water. And what your question is basically just what is the mass of the solid that you need. So like how much mass do you actually need to put in there to get to this concentration? That's your question here. So that's for the first one. So that meaning is combining a weighed solid with a solvent. All right, so that's option one. Option two is you take, I'm never going to draw a nice volumetric flask like that again, probably. It's not terrible, but okay. Option two is you take already solutions, a ready-made solution. So, all right, so maybe let me take a different color because I'm going to illustrate something to you using the colors. There we go. And I'm going to take let's take, there we go, that's that color. All right, so this is our solution here. All right, so that is what we start with. We say, all right, we take this first one, and we say, for example, all right, take 10 milliliter of this solution and put it in a new flask. Put it in a new flask. We take some distilled water. Okay, so there we take a little bit, a teensy bit of this thing, and we add water to that, right? So what's going to happen to this that we had now? All right, you can immediately see just by thinking of it, you had a very intensely colored orange solution, and you only took 10 milliliter of it. Now you're going to add up to, let's say, again, 2 liter amount of water. You're going to add to the mark of this. What's going to happen to it? It's going to, well, oops, it's going to dilute, right? So this whole situation here, it's going to dilute. So oh, now I just lost the color. I mean, that's fine. So let's just stick with the idea. So your sample here is going to dilute in color. Okay, so think about the lines that are going to change in color. So it's going to become less intensely colored, right? It's going to become maybe even a yellow. So maybe let's make it yellow. So it's going to become something like that. And you can do that again and again and again and again. And that's what we call the dilution. So literally you dilute the concentration as you would. I mean, so you can dilute anything that is concentrated. So if you take any concentrate, so like, I mean, I think of like Oros or any like something like that, and you dilute the concentrate, then you get a diluted version of it. All right, so that's the same idea as that. You make like a 1 to 200 dilution. It's the same idea. All right, so those are our two options. So option one, we were asked, suppose you need to prepare 2 liter of a 1.5 molar solution of aqueous sodium carbonate. You have some solid sodium carbonate, distilled water, and a 2 liter volumetric flask. So how much mass sodium carbonate is required to make this solution? How would you calculate that? Well, the answer is eventually we want mass sodium carbonate, right? So we want to get to a point where we say mass sodium carbonate is equal to something. And typically what we would want to get to is we want to say something like number of mole sodium carbonate multiplied by its molar mass of sodium carbonate. So how would you get the number of mole? Well, you have the volume and you have the concentration of the solution that you are looking at. So if you have that, then remember you can always calculate the number of mole of whatever you have making the solution of. So that would be volume of the solution, multiplied by the concentration of the solution, Na2CO3. So the volume is 2.00 liter, concentration is 1.05 mole per liter, which is molar. So that means we require 3.000 mole Na2CO3 required. And if you plug it in here, the molar mass is 106.0 gram per mole. Then you should get 318 gram sodium carbonate. Okay, so that's option one, or method one. You take the mass and you add enough water to make up a solution of 2 liter. Option two is you take the concentrated solution and you dilute it. So we can do that by another example. And in this example, it says, what is the concentration of iron 3+ ions in a solution prepared by diluting 1 milliliter of a 0.236 molar solution of iron 3 plus nitrate, FeNO33, to a volume of 100 milliliter. So the question is, what is the situation actually? And what do we know? So, I mean, you know the initial concentration and the volume of the iron containing solution. And we also know the final volume required after dilution. So perhaps the best thing to do is to first calculate the amount of ions, so meaning the number of moles that we have in this 1 milliliter solution. So that would be the amount is equal to the concentration multiplied by the volume. And then the concentration of the ions in the final dilute solution is equal to this amount divided by the new volume, right? Because the number of ions, so number of moles, is the thing that remains constant. We're diluting it, meaning its concentration changes, but the number of moles stay the same. The number of moles don't change. It's in a larger volume. Do you notice that? So it's 1 milliliter, and now we just take it to a total volume of 100 milliliters. So it says diluting 1 milliliter. So I'm just going to draw beakers here. So here we have a 1 milliliter solution, and then basically we add water. And now we have a big beaker that is in a 100 milliliter. So what happened here? We had Fe3 plus here, and we had a specific number of moles of Fe3 plus. And we just added water. And we still had Fe3 plus here. And do you notice that the same number of Fe3 plus moles are there at the beginning and the end? It's just in a bigger volume. Okay, and that is why, therefore, our concentration changes. Because the number of moles doesn't change, it's just the volume of the solution that changes. Okay, so let's say here, so we want to calculate the number of mole of Fe3 plus, right? So Fe3 plus is going to be equal to the volume of the solution. So volume of solution multiplied by the concentration of Fe3 plus, and that's given to us, the volume of the solution is 1 milliliter, so that means it's 1.00 times 10 to the negative 3 liter, multiplied by 0.236 molar. Remember, it's mole per liter, that's why we have to work in liter. So that means the initial number of moles, or not the initial number of moles, that means the number of moles is 2.36, or 260 times 10 to the negative 4 mole Fe3 plus. Okay, so that's what we have. And this is the number of iron in the 100 mol as well. So that just means the concentration of Fe3 plus final, we want to call it that, so the final concentration is going to be the number of mole of Fe3 plus divided by the volume of the solution, final. And that is this 2.360 times 10 to the negative 4 divided by 100 mole, which is, of course, 100 times 10 to the negative 3 liter. Why? Because we want a unit of mole per liter. We want molar, right? And that gives us a value of 2.36 times 10 to the negative 3 molar. All right, and if we think about this, do you notice that our volume changes from 1 to 100? So meaning the volume increased by 100-fold. And what happened to the concentration? the concentration went from 0.236 to, if we perhaps write this out, it's 123, so 0.00236. If you were to divide 0.236 by 100, do you notice that your concentration decreased by 100-fold? And that is exactly the effect of this. So that would be 100-fold dilution. Or maybe if you write it, if you want to make a 1 to 100 dilution. Okay, so that's the idea of diluting a more concentrated solution. And what typically would you want to do that? Well, for example, sometimes your situation is that you have an original sample, like something like seawater, which is way too concentrated to analyze in a lab. And you want to dilute it a bit so that you can work with something that's a bit less dilute and more analyzable in a lab. So as you can see here, it goes from very darkly colored to very lightly colored. And here it's 1/200th of the original concentration by transferring 10 moles and then transferring 5 moles, and each time filling to the mark. So adding distilled water. And I would seriously recommend reading this through about serial dilutions, because it's usually something that confuses everyone. All right. I think that's now a good point to stop. All right. So serial dilutions just basically means dilutions done in serial. So serial, like a series, like it happens one after the other. Okay, cool. As always, thank you for watching, and I hope you enjoyed the video.